All right, so I have here PV equals nRT, PIV, the ideal gas law, pressure times volume equals the number of moles times the ideal gas law constant, which is 0.0821 atmosphere liters per mole Kelvin, times the absolute temperature, which must be in Kelvin. Now, basically, we've already solved for R, and it's a constant. So R, we'll keep up in the corner here, R is always 0.0821 atmosphere liters per mole Kelvin. We don't have to worry about figuring that out again. That's what it is. It's a constant. It always works. It always works as long as your pressure is measured in atmospheres, your volume is measured in liters, your quantity of gas is measured in moles, and your temperature is an absolute temperature in Kelvin. So you have to use atmospheres, liters, moles, and Kelvin for this to work, but it always works. It's universal. It's a constant. Now, what do we have to be able to do? Well, we got to be able to do a little bit of simple algebra. We have to be able to solve for P sometimes. Of course, if we need to know the pressure, we must already know the volume, the gas law constant, which we always know, the number of moles, and the temperature. Okay? And we know, yeah, if you heat it up, it's going to change the pressure, and if you cool it off, but whatever circumstances there are, we should be able to plug them in and solve for pressure. If we know the pressure, and we know the moles, and we know the temperature, and we always know the gas law constant, we should be able to solve for the volume. And similarly, while me talking through the whole thing, I should be able to rearrange this to solve for moles, and I should be able to rearrange this to solve for temperature. Now, what I need you to do here is, and I actually need you to do it, is I need you to pause this video, and I need you to do that algebra on paper. I need you to take this, I need you to put it on paper, I need you to do the algebra that's necessary to isolate P. Once you get that answer, I need you to start with this again, pause the video, do what you need to isolate V, and to isolate N, and to isolate T. So please take a piece of paper, pause your video now, and do that. We're not talking about doing, putting any numbers in. We're just talking about rearranging the equation to isolate each of the four variables that we might have to isolate. And after having completed that, let's see what we got. If I've got pressure, look at where pressure is here. Pressure is N, R, and T are already on the other side. N, R, and T are already on the other side. So what do I have to do to isolate P? I need to get V out of the equation on the left and somehow move it over to the right. So the way I get it out of the equation on the left is divide both sides by V. And when I divide this side by V, V is going to cancel. But now V is going to be over here in the denominator. And that's how we arrange the ideal gas law to solve for pressure. Okay, let's go ahead and put a box around that and save it because we need to have that for later. Now we take a look at V. Well, V is very similar logic because V, in its initial form in the ideal gas law, is over here on the left, and R and T were already over on the right. So what do we have to do to isolate the V? We have to get P out of there, and the way we get P away from this side is to divide this side by P. But the way algebra works, if I divide this side by P, I must also do the same thing on the other side, divide that side by P. So now I have this variation on the ideal gas law rearranged to solve for V. To solve for N, well, here's N, P and V, and I know that I'm on the right side and I'm switching over to the left side, but which side it's on doesn't matter. Okay, I could easily flip these. Okay, it doesn't change the value to flip your left and right side as a whole. Okay, you know what? I'm going to go ahead and do that. Let's get rid of this and say it this way. If PV equals nRT, then nRT must equal PV. Okay, maybe that makes it a little bit easier to understand. So here's N. P and V are already on the other side. What do I have to do? I have to get R out of the left over to the right. I got to get T out of the left over to the right. So on the left-hand side, if I divide by r and I divide by t, then r and t will cancel on the left, but I divided by those two variables, so I have to do the same on the other side. Okay, and so now I have a third variation of the ideal gas law rearranged to solve for n. And then finally, if I want to solve for t, here I got t on the left. Pressure and volume are already on the other side. I don't have to do anything with them. But if I want t by itself, I have to get rid of n and r by dividing both sides by n and r. And so now I have 4 variations on the ideal gas law constant that I can use to solve for any variable that I don't have. And of those variables, r is always the same. R is always 0.0821 atmosphere liters per mole Kelvin. And that, I guess, is a given. We can always go with that, and it will always work. Now, as of now, I'm not going to assign any problems today where you have to solve for these. Okay? But our next set of assignments are going to be problems that you have to take the ideal gas law, take information that's given in a problem, list the given, take the ideal gas law, and either pick this or this or this or this, whichever one's appropriate, and solve for the variable that's missing. Okay, so today's posting is understanding what the ideal gas law is, what standard temperature and pressure is, what standard molar volume is. And our follow-up will be to actually take these equations, take this value. I will give you data for 3 of the 4 variables and have you solve for the 4th. Okay, it's pretty straightforward algebra.